Hey guys, welcome back to week 2 of data structures. So hopefully you made it through week 1 perfectly fine. This is one class that you don't want to get behind because it's a little bit more challenging. This week I will provide some additional video besides this video about a lab. So I'll walk through and show you how to write some code in JavaScript. Not specifically your homework, but something very similar on how to work with stacks and queues and so forth. So this week we'll discuss chapter 3 and 4. First thing that we'll kind of talk about in this lecture is the stack data structure, the ECMA script and stack class, and solving problems using stacks. So remember this terminology: stack, LIFO, last in, first out. So you could come up with an acronym that makes you remember that, but last in, first out means think of it as the last person in, but the first person out. So think about this: you're standing in line to go to a movie concert, and there's 10 people in line, which is probably very rare. Say you're a stage AE on the North Shore, and you're waiting in line, and there's like 100 people, right? And you're 100 person. So obviously you're the last person in the building. But once you get in the building and they say, hey, guess what? Everyone has to leave for whatever purpose. Maybe there was a fire alarm pull or whatever the case is. Think about it. You're the last person in and you will be the first person out. And that's how that works there. And the queue is the first in, first out. So in this case is, let's say you go to a theme park and you're waiting in line to say, get on the new ride at Kennywood. And you're the first person in. And in this case, you'll be the first person out. And it shows you how that works. Last in, last out. And this is with data structures when dealing with certain specific data types, and you're kind of running algorithms and searching for information. This is very helpful. Moving on. All right, examples of stacks: converting a decimal number into a binary one. A stack of books. The Tower of Hanoi. Finding your way back, and undo and redo operations. So in this case right here, look at this data structure: basic, empty stack, so there's nothing in there. So first thing we do is we push a data volume in here, which is number 1, and then we push another one which goes on number 2, so we start stacking them. So remember, push means to add. So when say dealing with arrays, or even let's say that you're working in Excel or you're writing an email. What are you doing? You're pushing. Pushing means you're adding to something that doesn't exist. So you keep appending. If you ever heard the word append, means if you're building some, like take a content management system, say WordPress, for example, and you're building a page and you're adding information and it's storing information and storing it into a string, it's storing it into a variable, but it's appending each value. So it might have value number 1, comma, value number 2, comma. That's what the push is for. The pop means what it means. It pops out. So once you do the pop on whatever index number it is, then that value will pop out and move over. Okay? That's your stack. And then your queue is like here. We use the terminology enqueue and dequeue. Enqueue means to add on. Dequeue means to pop out. Okay? If you have questions on that, please let me know. Books, common theme, things that have been reversed. Books, you might pull this one right out. You might pull that one out. You're not going to pull them out in the same order every time. All right, so the Tower of Hanoi. I would definitely recommend you to Google this, Wikipedia. It's an objective of a puzzle is to move an entire stack to another rod, obeying the rules. So only one disk can be moved at a time. Each move consists of taking the upper disk from one of the stacks and placing it on top of another stack. And no disk may be placed on top of a smaller stack. So in this example here, you're taking one item, putting it over another, and it's giving you a visual example of what a stack is and how it works. So when going from A to D, push each direction onto a stack. You go to A, which is the origin, your first start. B, C, and D is your last location. But when you pop them out, remember, push, pop, you go from D to A. Because D is the last one that was in. So same thing with that person and last person in line. They're going to pop out first. Then C, B, and A. So remember, push. In this case, we're just popping out. Hopefully that makes more sense. All right, undo or redo operations. Example, Microsoft Excel. Use 2 stacks on for undo and 1 for redo. If a user presses undo, then what? So think about it. You're in Excel, you type something in, or even Word, and you go at the top and you click that little arrow pointing to the left, which is undo. You're popping an action from the undo stack. So let's say that you had this sentence here and you're like, oh my gosh, that doesn't make any sense. You undo, takes it back. So you're popping the action from the undo stack and removing it. You're undoing that action. You're pushing the action to redo stack. So the right arrow to the right is maybe you have something else that you want to add in. If a user presses redo, then pops the action from redo stack, if any, redos the action. So what it does is, let's say that you're writing a sentence and you're writing this, you're writing your resume, and you put your information in for your resume, and you're like, oh, you know what, I don't want to do that, so you undo it. Then you're like, okay, maybe I want to redo it, so then you redo it. So it's the ability of utilizing those little arrows left and right at the top on Word, or if you're using Excel, or even PowerPoint for that case. You have the ability to go left or right, which now think about a different philosophy. Think of push, think about the different objects that we talked about. All right, let's move on. So when I say different objects, think about these guys. I'm gonna go back for a second here. So think about the push to pop. All right, a couple other things. When a new action is performed, clear the redo stack, so clear it completely, and also works backward and forward in the browser. All right, so our review, very limited. Last in, first out. Common themes, things that can be reversed. Examples, converting a decimal number into a binary. I can't talk today. Binary one. Let me get a drink of water. Stack of books, the Tower of Hanoi, finding your way back. All right, that's much better. And undo, redo operations. We're talking about constructor, which is a stack. And the methods within the constructor are push, pop, peek, is empty, size, clear, and print. Now, we didn't talk about peek, but in the lab, I'll go over that. All right, chapter 4. Talking about the queue data structure, creating a queue, the priority queue, and the circular queue, hot potato. That'll be part of your assignment. Stack, last in, first out. Queue, first in, first out. So waiting in line. So you're waiting in line for a concert, a movie, big movie just opened up. Line, it could be line of cars at a light, very common. Line of documents for printing, very common. If you work in a corporate office or location, or even in class, you have multiple people printing, and you're just waiting for yours to be printed out. And then line of packets of a router. Like, so when you're on the internet and you're sending information back and forth, whether you're watching a video or sending a video, whatever the case is, packets have to be sent. And computer multitasking. So in this example here, I did the queue line for Rock and Roller Coaster. Now this is an older ride at Disney World. It's been there for about 20 years at least, but and the funny thing is, it isn't really that high, and it goes upside down very quickly. It's a very fast ride, but the thing is, people stand in line, people waiting there for hours. So this is just one example of standing in line, first person in, first person out mentality. So think about that next time you go to a theme park or a concert or a sporting event. Think about a data structure and how it would apply to the position that you're in. All right, For a long time, computers only controlled one CPU and one core. So growing up, when I was growing up, they had the computer, the 486SX, the 586SX, and those were super fast, but hard drive was maybe 500 megabytes, maybe not even that. But they had one CPU, one core. Now computers are super fast. They could have multiple CPUs, multiple cores, and it just makes it so much quicker. So how do we run 50 programs on 1, 2, or 4 cores? So in this example here, showing you a system with multiple CPUs, the socket processor, the core. See, before my time and probably your time, computers were like so big, so large, and all the work they did was not compared to what a laptop can do today. Is that amazing how far we've gotten in the computer industry, where a computer 50, 60 years ago would take up the size of a traditional 12 by 12 room, or maybe even larger, to do very minimal stuff, where our laptops could do, or even our phones could do much more than that big room could be. So that's how we've advanced in technology. Our review talked about the queues, the stacks. This time, within the methods, we're using NQ, DQ, front, empty, size, and print. Once again, any questions, which you probably don't have any because you're online. So watch out for my video. I'll post it either on Sunday or Monday, and it'll be a lab that walks you through a better understanding of writing the code to see how it works. And if you have any questions, please reach me on Slack. I would prefer Slack. It's a better way to reach me. And all right, well, thanks for watching, and have a good week. And that's it. Bye for now.